Hello everyone, myself Ashit Desai, Assistant Professor, Shell Institute of Technology, College of Engineering. Today we are going to discuss on robotic programming, Vol 1. So we are discussing the robot language. So in that we are going to discuss first that is generation of robot programming languages. So firstly, there are the criteria which are having the three classes in a robot language, that is first generation, second generation, third generation. So we'll focus on first two generation, then we are discussing the third generation language. So in first generation language, the use of combination of command statements and teach pattern procedure for developing the robot programs. So while developing the programs which are we are having in the offline mode programming, which is with through the teach pattern, sometimes which is referred as a motion level language. So it is capability to handling of sensory data and communication with other components, which is limited one, and that is why the programming instructions can be used in a define the sequence. So it may be move like that move commands or input output command is in a wait signal, and they can be used to write a subroutine and is in a branches. So this is commonly it is utilized in a first generation language. So here there is a complexity in a while computing the arithmetic calculations and use of the that make a complex sensitivity we are not capturing here. It is limited, so that is communication is less in this generation. So this is limitations we are able to come up out there, that is about the first level generation. So the example is variable assembly language, or you can say versatile arithmetic language. So versatile algorithm language, so it is in considered as a first generation language. So now we are come up with a second generation language. So we are going to discuss this first and second generation. So in second generation, we are overcoming the many of limitations of first generation, and there should be addition of the capabilities, and which is incorporating with the some intelligent points over there. So we are generating the different complex motions through this second generation, as well as we are performing with analog and digital signals, which is beside the binary form signals. Also we are advantages with a better interfacing facility with other computers, as well as data processing and the file management, and keeping all the records of events happening in the cell, and that can be done in an efficiently way. So this is the example we are having the language that is about a manufacturing language, that is AML, or you can say RAIL, that is about robotic atomic matrix incorporated language. Also RCL and the wall 2, etc. That is the second generation language, which is come up with the first limitation of generation, and this is the knowing about the robot generation language. So in this concession, we are having the feature and abilities of the second generation. So what are the new features which is added in a second generation? So first is about motion control. So in that sophisticated control movements, the allowing the precise and complex motions. Also, we are facilitating with the smooth motion planning and trajectory generation. Also, which is useful for the coordination of robotic actuators. So this is about the motion control. So it is controlling the robot movements. It is possible. And secondly, that is about advanced sensor capabilities. So it is integrating with a wide array of sensors, and which is gathering the data, and that is the data types we can identify, and in that environment we are getting the decisions. So the sensor capabilities like lidar sensor, we can use cameras, the proximity sensors and other specialized sensors for actuation of object detection, as well as localization and mapping. So it is possible by the advanced sensor capabilities which is added in a second generation language. Also we are having the limited sequences. So in the creating the step by step procedure, so there are should be their actions will be performing in a predetermined task or routines. So this task will be having in integrate manner, so we can able to the we are dividing the specific task programs. So sub programs we can divide it in this way. So we are limiting sequence programs will be there. So the size of the programs will be less. So this is about the limited sequence. And the next is about communication and data processing. So the communication between robots and external system is more equipped with this, and as well as it should be useful for the conditionalize, and it should be helpful for the different protocols and the data transmission, as well as it can improve the in network capability. So these are the features, uh, these are the features we are adding over there, and efficiently data will be processes, and we can make the decisions over there which is based on the incoming informations. So this is about the facility we are creating in the second generation. So this is about the robot language structure. So here the robot controllers we are taking from the teach patent, as well as we are having the positions we can getting by the teach patent. First of all, we are getting the orientation of the initialization of the robot. That time we are taking the operating system mode, and then monitor mode we can taking the actions and logical sequence we can arrange in the programming instructions, and then communicating with the computer system, and then it is fed to the robot controller, and it is actuated with the system. So we are taking the feedback from the sensor also and other peripheral devices, and then robots will be manipulated. So after that we can take the benefit of that, and then we are taking the feedback to the robot controller, and if it is necessity to change any type of program, so we can do the changes in the programs, and then we can do their actions in a suitable manner. So this is about robot language structure. Then in that structure, that structured language, we are having the some elements and the functions. So there are some functionized, there should be requirement is in constant variables and other data objects, and then motion commands, end effector and sensor commands, computation operation, program control and subroutines, communication and data processing, and monitor mode commands. So these are the points we are discussing one by one for the actuation of the functions. So first of all, we discuss the constant variables. The constant is used in the program that does not change and during the execution of program, but variables is be symbolic, and it is can be changed in the value for the execution of the program. So constant and variable, there is a difference, that may be in integer, or you can say real numbers containing a decimal point. So this should be enclosed in the quotes, and the integer and real numbers, it should be indicated in the values of plus or minus, so that sign also we are presenting over here. So these are the constructive work in the constant and variables. Samely we are discussing the robot language function in this, that is about motion commands. So we are operating the move a1, that means what, move to point a1. So like that we can define for the wall one language, so move to point a1, that's why we are writing in a instruction, that is program instruction, that is move a1. Then also we are reading in a moves s1, so that is means what, straight moves in along in a direction of a1, so that is about moves a1. Then move a1 via v2 a2 means what, uh, the the robot or manipulator moves in a1 through the a2, so moves to a1, so moves to a1 through a2, so a2 is the moving distance and approaches to the a1. So this time we're writing as a like that, move a1 via a2. The next is approach a120, so approach a120, that means what, suppose we are approaching point as having some distance, and we are approaching from the distance from the 20, so 20 apart distance we are approaching that point, that is a1. The next is moves a1, that is straightly move in a1. The signal is in the format signal 1 2 3 4, like that we are getting the information to close the gripper or open the gripper. So that is about the signals. Then depart 50, so this is the command we are using for the depart 50, means after reaching that point, that is about away from the 50. So this is about the main thing we are having the motion command. So it is related the moment of the robot, so we are getting the information for the motion commands. The nextly we are having the hand control. So in that case, the opening of the gripper during the next instruction, so you can use the command that is open. Close the command that is about the closing the gripper during the next instruction. Then open eye, that is about immediately open, or you can say open eye. Secondly, that is about close eye, that is about during the closing of the gripper. So we are having the closing the gripper side, so that is about close eye. So this is the same function as between the open eye and close eye. Then next is about the move straight, a move st, that is part 30. The servo controlled end effectors causes a straight line motion to a point defined by part and gripper opening is changed to 30 mm. So this is about move straight line, the part and defined by the point, and then changed the opening to the 30 mm. So only changes up to the opening of the gripper is about 30 mm. So it is limiting value we are providing also in this case, that is about hand control. The next is about move T. So it is gripper to move the position and part with an opening 30 mm by joint interpolated portions. So this is about the main thing about the hand control. Then nextly, that is about end effector and sensor commands. So in this case, open or close, that is about wait or next motion. So we can consider as an end effector. So open eye, close eye, that is immediately open or immediately close. So we can use the open eye, close eye. The close 40 mm. So only the gripper should be closed up to 40 mm. So limiting value we are providing over here. Then close 1.575 inch. So it is in value of inch. So that is opening value for the gripper. So that's why we are writing is a close 1.575 inch. So look at here. So here only we are not we are using this command which is in a programming instruction. So close 3.0 lb, that means what, gripper force we can make can be applied over here. So that is about the close 3 lb. Then center does not move the objects, that is about center. So this is about center does not move to the object. The next about end effector command, that is about operating for the tools. So operating tool which are having the speed, torque and time. So at the time we are using the speed which is required speed, we can writing over here, that is about 1.125 rpm, that is revolution per minute. And then torque is in between the 5-inch lb. So this is a mentioning condition for the operating as a tool. Then time for 10 seconds. So this is about limiting value for the timing. So this can be limiting by the end effector tools. So this is the approach we are writing in a programming instructions. So now turning from the output signal. So that is about signal 3 on and signal 3 off. So that is port number 3 should be utilized for the turn on and off for the different time of instance. So we are using the signal 3 and 4 signal 3 and signal 3 on off. So we can maybe use for the condition, that is about on and off output signals. Then signal 105, comma 4.5, the command will provide an output point 4.5 unit within the allowable range of the output signals. The wait command is used to verify that the device has been turned on before permitting the program to continue. So this is about the wait and signal 105.4.5. So 4.5 units is about output voltage, so that can be generated, then only the opening will be possible or not possible. So this is about the permitting value, so we can provide in the sensor commands. Then computation and operations. So computation and operations, so we are having the user for arithmetic and logical instructions, which is an expression will be for the left and right with parenthesis used to indicate that expression inside the when that value will be first. So calculation is also possible. So that is glimpses of the some computation values and operation values, that is by addition, subtraction, that is arithmetic calculations we can do here in this. Also we are having the trigonometric functions we can operate over here, that is by trigonometric conditions. Nextly, we are discussing this point in this relational operator, that is equal to, greater than, less than, then not equal to. So like that functioning is also possible, that is by relational operators. So in that languages also we are mentioning the relational algorithms also you are using over here. Then exponential format, as well as we are having the similar type of logarithmic function also we are available with this, that is about computation and operations. Then communication and data processing. So here we are having the robot with other system based, that is peripheral from the storage device and printers. So we are developing for the that conditions we are having the common devices CRT, that is about plotters, buzzers and speech synthesis. We are communicating with also their possible devices like joysticks and light pin and speech recognition system. So also we are having these conditions, and that is about the approach for the communication and data processing. So this is about the introduction about the wall programming. Before that, that is condition of force, fully we can consider the first generation. And this is about the main consideration for the that instruction about your programs, and that is about the discussion level for the first this session, that is about wall programming. So that is the content we are discussed over here. Thank you.